Engineering students often want to tackle big problems like world hunger, inequity in healthcare, global warming, access to clean water, or space exploration. It's hard to make meaningful progress in one semester or a year, 5 years, or even a career. However, you can tackle smaller problems in those areas and make progress if you have a well defined problem statement. For example, you might want to tackle jaundice treatment in newborns in Africa, or reducing emissions in SUVs for the Ford Motor Company. A well defined problem statement can follow the model of who needs what because of why. This model works well for user centered or need driven design. The who in this statement is the user, or the person who has the problem. The what defines the solution space. The why is the heart of the problem statement and explains exactly why the user needs the solution. Exploring the why is the focus of this video. You must have a clear understanding of the problem so you can be sure you are solving the right problem for your client or user. Sometimes students actually misunderstand the problem and create a solution that solves an adjacent problem. Sometimes students confuse the goal of the project with the problem, i.e., they confuse what's needed with the why it is needed. It is important to acknowledge the problems are often complicated and nuanced. Problems can be recognized by experts or someone familiar with the situation. Sometimes problems are not seen by the user and require a new set of eyes on the situation. But in this class, we won't be asking you to do the difficult task of identifying the problems. Rather, you should be starting with a scoped problem. To fully understand the problem, you need to ask lots of probing questions. You need to challenge assumptions. You need to dig in and explore the nuance. One way to dig deeper into your problem is to implement the 5 whys method. The 5 whys method was developed by the Toyota production system for optimizing manufacturing. The 5 whys is a root cause analysis tool and is used to help you identify the why of your problem statement. When using the 5 whys, it is important to involve people who are familiar with the specifics of the problem. This is usually your users and/or your client. When using the 5 whys method, you ask the question why 5 times. Let's look at an example. A student was late to class. Why was the student late? The student may have missed the bus. Why did they miss the bus? The student was late leaving breakfast. Why was the student late leaving breakfast? The student went back for a second helping of waffles, which took a long time. Why did it take a long time? The line to use the waffle maker was long. Why was the line long? There was only one waffle maker. The root cause of this problem was that there was only one waffle maker. However, consider that some things could have multiple causes. The student can also respond to, why was the student late leaving breakfast? With, the student was late getting to breakfast, which might also lead to the following. Why was the student late to getting breakfast? The student overslept their alarm. Why did the student oversleep their alarm? Because they were overtired due to going to sleep late. Why did they go to sleep late? Because they stayed up late doing their math homework. Why were they up so late doing their math homework? Because the student didn't start the homework until late in the afternoon. The root cause of this problem was that the student had poor time management the night before. Some problems have multiple root causes. In your design project, your team should typically focus on one root cause for a problem. It is also important to ask the right why questions and to ask different whys to sort out many possible root causes. If we had asked, why did the student need a second helping of waffles, we might have come out with a different root cause and thus a different problem to solve. You can find some answers to your why questions in your project brief, in the project background, or in the problem context. You will still need to ask why to your client and potential users to get the root cause of the problem. Your users' because statements may explain the existing situation, limitations, or conditions. It may explain why the problem is not solved, or may reveal bias, assumptions about the problem or potential solutions. These becauses often become the why part of your problem statement. This can help you write a cogent problem statement of who needs what because of why. Sometimes clients or users will jump to or specify a segment of the solution space. In other words, they may narrow the what unnecessarily. They skip over truly understanding the problem fully and just want the problem to go away. At the outset of tackling a design problem, try to avoid jumping to solutions, which is the what of the problem statement. There will be plenty of time to focus on finding specific solutions later. As you approach the solution phase of the engineering design process, narrowing the what of the solution space in conversations with the client and or users can be helpful, as it allows your team to focus on a range of potential solutions. However, at the start of the design process, we need to learn the why. We want the what to be vague now. Some generic examples of why are that the existing solution cannot do something, i.e., it lacks a particular function. It may lack an important feature of characteristics. It may cost too much or work for some but not all of the population. Alternatively, there might be no existing solution that meets the need at all. Sometimes there may be a unique opportunity to take advantage of. An example of a well-written problem statement is local volunteers need a way to filter trash out of Ellerby Creek because the trash in the creek is damaging the creek's ecosystem, including its plants, animals, and fish. The who? Volunteers. What? A way to filter. Why? Trash in the stream is damaging the ecosystem. Note that the solution space is narrowed to getting the trash out of the stream. A broader problem statement could have been to try to stop trash from getting into the stream in the first place. Sometimes the reasons are more complicated. Medical staff need a way to monitor 4 different newborn babies that are placed in one incubator. In low-income countries, many babies are placed in one incubator due to a shortage of incubators. Incubators are designed with only one temperature monitor, and thus some babies may have temperatures that are out of range, and the medical staff is unaware. The who? The medical staff and the babies. What? The temperature monitor or reporter. Why? Several babies in each incubator are not monitored, and if they are out of range, this can lead to dangerous complications. Some features of awesome problem statements include they're specific, they don't contain a solution, or they state the limitations, gap, or opportunity that exists, and they are 1 to 2 sentences. A good problem statement will funnel the large general problem in a more specific, focused problem that we can solve. So, instead of tackling global warming, you will work on tailpipe emissions of SUVs. Features of terrible or poor problem statements are too big or generic. They're vague. They may contain a specific solution. They may restate the goal or just say the client wants. In summary, a well-defined problem statement can follow the model of who needs what because of why. Focus your time at this stage of the engineering design process to really explore the why. Consider using the 5 whys technique to get to the root cause. Truly understanding the reasons motivating your problem will situate you for a successful design project.